We're going to look at the quadratic formula in this video. So, first thing we need to look at is the discriminant. The discriminant is taken out of the quadratic formula. We have b squared minus 4ac. That's minus, not an equals. There are various conditions written underneath. You can read them all. I'm going to skip ahead and actually just do it. So, for each of the quadratics, calculate the discriminant and hence state the number and types of factors and whether or not complete the square method will be needed to obtain the factors. So, first one we have a equals to 2, b equals to 15, c equals to 13. Putting that in the discriminant, we get 15 squared minus 4 times 2 times 13. 15 squared is 2.5 minus 8 times 13 gives us 104, which is then 121. Now, this is greater than 0. That's good. If you have a perfect square for the number, which this is because that's 11 squared, the factors are rational. So that means we have two solutions, and we also have rational solutions. Oh, sorry, two. I should just put them together. So these are two rational solutions. All right, B. 5x squared minus 6x plus 9, so we have b squared minus 4ac, which is 180. You don't have to do it how I'm doing it, where I'm doing it in my head. You can put it in the calculator. Alright, we have a negative solution, so there are no solutions. C. Now, don't forget your negatives and positives. Your first, because we're doing b squared, the negative doesn't really matter because we're going to square the negative, but for the other ones it does matter, which you'll see in a second. So then we have b squared, which is 9, minus 4 times a negative 3 times 8. That then becomes a plus. So we then have 96 plus 9, which is then 105. 105 is not a square number, so then we have two irrational solutions. And last but not least, D. We have b squared, which is 144, minus 4 times 81 over 4 times 16 over 9. So the 4's cancel there. 9 goes in 81 9 times. So 144 minus 144, which is 0. If it's 0, we have one solution. If you like, it's always rational. It's always rational. I should probably write one rational solution. Alright, quadratic formula. Once it's in the form a squared plus bx plus c, you then just substitute it in the formula. You should have seen this in year 10, so I'm not going to go through it too much. So expand it. Put them all to one side. I'm going to put it to the right, so then the first number is positive. We have 5x squared minus 9x plus 3. Then x is equal to b squared plus or minus, b, not b squared. The second one is b squared minus 4ac all over 2a. So negative 9 plus or minus 81 minus 20, so 60 over 10. So that's negative 9 plus or minus square root of 21 over 10. Alright, use the discriminant to determine the number of solutions and the type of root to equation 1. So, same as before, b squared minus 4ac minus 4ac 64 minus 300 plus 300. Sorry, oh my god, what is going on? So that's 364. That is not a square number, so then we have two irrational solutions. Okay, B. Now this is a common Year 12 question. It often pops up every now and then, so make sure you know how to do this one. Find the values of k so that the equation will have one real solution in the answer. Now, you might notice there are two sets of k's. What I'm going to do first is I'm going to actually put the x's by itself, and then I'm going to put the rest of them as one group, because if you write it this way, you can see that a is equal to 1, is equal to k, and then c is equal to and quite often a lot of people just forget to write it together. So make sure you do, because when you put it in the formula, you then get k squared minus 4 times 8 minus k. A lot of people forget to multiply the whole thing. Alright, this has one real solution, so that means it's equal to 0. Then simply solve it. We have k squared plus 4k minus 32 equals 0. That's 8 and 4. So then k is either equal to -8 or it's equal to